I'm going to have to get rid of my example one here, the general one, and put on a specific one. So we're going to apply this orange tactic, we'll call it, to this orange problem. So the original function is y equals x squared. If you would sketch it, you will not have to sketch it for a class. This is just the learning curve. So we're putting the curve up there to help our learning. So in this case, we actually know the inverse function, and you won't have to find that. But we can see that what would undo this function, the square root. So if we call this the original function, and this is the square root function, is the inverse function. So what I want to do is answer this question. Find the derivative of the inverse function at x equals 4. Find the derivative of the inverse function at x equals 4. The thing where we get tripped up in these problems is the fact that the x on the inverse is the y on the original, and the x on the original is the y on the inverse. So the way I've written this problem, which do you think I'm giving you? Am I giving you the x on the inverse function, the one that would be sitting here, right there, or am I giving you the x on the original function? Just from the way this is reading. Morgan, what do you suspect? You might be wrong. Find the derivative of the inverse function at x equals 4.
I feel like it's the inverse one.
It is, so that's the x on the inverse function.
So it's the y.
And the y on the original. Very good. So I'm going to make a note of that. Of course, you're not going to be drawing this. You're not going to be coming up with the inverse function, and you're not going to be identifying it. This is all training. So bear with me. Find the derivative of the inverse function at x equals 4. So this is the x value on the inverse function. And also, as Morgan said, it is the y value on the original function. All right, those in video land, if you can't read this little squished up statement here, I'll just read it to you and you can pause and write it. The x has been identified here in this question. Find the derivative of the inverse function at x equals 4. Because the word inverse function is in the question, they are giving you the x value for the inverse function. So that's the x value of the inverse function, and it is also the y value of the original function. So you got to keep those straight. It's the only tricky part to this whole thing. So if I want you to find the derivative of the inverse function at x equals 4, what you will do, we found that there's a reciprocal relationship. We're going to start with the original. What's the derivative of the original? Jonathan, are you up with us? Are you still writing?
What do you ask?
What's we've learned there's a relationship between the two derivatives. We're being asked for the derivative of the inverse, but if we know the derivative of the original, we just take the reciprocal of it. So what's the derivative of y equals x squared? That's what I'm asking you, Jonathan.
2x.
Right, 2x. So then you want the reciprocal of that, which is 1 over 2x. But I'm putting that line, and I'm going to put down next to that line the number that I'm going to insert into the 1 over 2x. And I don't know if you've seen that notation before. It just means evaluate this expression at the number given. So I'm going to use that notation. So what number do we put in if we want to evaluate this here? We need the x value of the original. So we don't have that right yet. So how could I find it? Gianni, what could I, this is the x value. So if I go in here, we already said it's the x value of the inverse. So it's this. So that means it's also the y value of the original. So how can I find this value?
You could set the original equation equal to it.
Right. This is the y value. Can you not put it in here and find x? So when you do that, what does it become, Gianni?
X would be 2.
Or negative 2, but you can see that these are over in the positive area. So we're going to say x is 2. So this was calculated. So I'm going to write it in. I'll underline it because it wasn't given. We had to calculate it from the expression. So I'm going to evaluate that reciprocal at the x value of the original function. And normally the problem does not give you that. It gives you the x value on the reciprocal, which is the y value on the original. So now when we put that in, we get 1/4. All right. My apologies for going so slow and acting like you're so stupid, but you will thank me later, okay? So I'm going to give an example. Then I'll go back and fill that in with the rest of the math ease that we need. All right, Jonathan, where art thou? Have you got this? Have you got this middle part?
Yeah, you can already see it there. Just not the bottom.
Okay. All right, here's an example, and I don't mean to scare you because they're really a simple problem, but they're easy to get befuddled on. So, all right, let's see. Here's an example. I'll do it, and then I'll give you one to do. Then I'll fill that in, and then I'll give you another one to do. So in yellow, here is the function we're going to talk about. If it helps, think of it as y equals either one, whichever assimilates in your brain the best, that's the one we want to do. First of all, I want you to verify that it has an inverse function. So first, will always be the first step is to verify that there even is an inverse function, and then find the derivative. Find the derivative of the inverse function. At a equals 26. And we'll talk about that a in a minute. There's the example problem that I'm going to work with you for you, and then you should be fine after doing this. All right, we're going to use the method that I described over here. We're not going to find the inverse function. We're not going to sketch it. We're just going to do it with the principle that we learned about the functions having reciprocal derivatives. So, first of all, verifying that it's an inverse function, the quickest way is to find the first derivative and see if it's always positive or always negative. So, I'll move that up closer to the problem. Morgan, what is the derivative of this expression?
3x squared.
All right. All right. For any value of x, negative or positive, do you see that that's always a positive expression? All right, so you can just say always positive. And just put a little check mark, and that shows me that you have proven to yourself that it does have an inverse function. So, first that takes care of the verify. Now we're going to find the derivative of the inverse function at a equals 26. I think your book goes out of its way to try not to confuse you with the x and y stuff. So it says a equals 26. But what it's saying is that's the x value on the inverse function. So I'll write that down. X value on inverse function. Is that the one that we will plug into our problem at the end? No, it is not. All right, so just keep that under your hat. And let's go ahead. Let's find the derivative. Let's find the reciprocal of the derivative. We already found the derivative, so find the reciprocal. And all we have to do is evaluate it at some number. But what will that number be? As you can tell from our lengthy discussion, it is not 26. So again, Morgan, can you describe for me where I can go on this board with that 26? Because that's the x value of the inverse, but it's the y value of the original. And I'm trying to plug in the x value of the original. So where do I go to find it?
You can plug the 26 into the original
Right.
as the y.
Right, there, at the f of x, which is the same as the y. So you can move the 1 over, it becomes 27, and take the cube root of 27, which is a 3. So now we know this value is a 3, not the given 26. And you get 1 over what, 27 when you plug it in? And that's the correct answer. All right, let's go back up to the expression and fill in the blanks. I think if I started with the definition in math lingo, it may not have made as much sense as it will now, I hope. All right, how far are you? I want to erase some things. Is this orange okay?
Yeah, except for derivative or original 2x, I'm writing it.
Right here?
Yeah.
Okay, I'll get rid of this. Can you tell how many minutes we're up to?
You mean till end of class?
Now on the video.
Oh,
It might not say. I think we were timing it. That's okay. I can split it up if I need
yeah,
to.
it doesn't say anything.
Yeah, it doesn't. You're right. All right. We've probably gone over 10 minutes, don't you